All right, hi, welcome to the spring semester final review. This is going to be part one. Let's get into it. All right, here we are graphing transformation 6.3. When we look at transformations, we use the equation y equals a times the square root of x minus h plus k, where A represents a vertical stretch or a vertical compression, H represents left or right movement, and K moves up and down. So with this first one here, first thing we see from left to right is a negative. That negative tells us that this is a reflection over the x-axis. Next, we have the 1/4. That is our A value. And A is 1/4, which means this is a vertical compression. H is next. H is +3, but we remember x lies, so H is actually -3, which means we have a shift left. And then lastly, we have our K, which is -5, and this is a shift down. And we can go ahead and talk about the different letters and what they mean. A is either a vertical compression or a vertical stretch. I guess I can specify that by saying if A is less than 1, it's a vertical compression, and if A is greater than 1, then we have a vertical stretch. Next for H, we remember that X lies, and so if it's positive H, we move right, and if it's a negative H, we're moving left. Last we have K, and K, if it's positive, it goes up, and if it's negative, we go down. All right, so now moving on to the next problem. What is the equation for this graph? Hint, the parent function is the square root of x. So let's take a look. All of our parent functions start at 0, 0. So we moved from 0, 0 to this point here. So that means we went down 5 and to the right 5. So we know because we went down, our k is -5. And the one that moves left to right is h. We went to the right 5. With h, we remember that x lies. So although the real value of h is -5, in the equation, it's going to say +5. So we're going to say y equals the square root of x plus 5, and on the outside is our k -5. We can also look at this from another standpoint too. This is the vertex of our square root function, and the vertex is at 5, -5. We always said how our vertex, the point x and y, is hk. And look at our h, look at our k. So two different ways of doing that here. All we did was plug in h and k to our transformation equation. All right, moving down. What is the domain and range for the following function written as an interval? All right, anytime you're given an equation and it wants you to describe what the graph looks like, whether it be domain and range or what the vertex is, what the max or minimum is, all you got to do is stick that in the calculator. Make it easy for yourself. Use your resources. All right, so our equation here is y equals 6 times the square root of x and then on the outside we have minus 1. Here's our function, and it wants the domain and range. So if we're looking, here's our vertex down here. If we're looking at the domain, we say the domain is the x values from left to right. So from the left going towards the right, our lowest x value is at 0. And as we head to the right, our graph also continues to the right towards infinity. So our domain here, this is x left to right. The domain is 0 to infinity. Let's look back at that image. Starts at 0 as our first x value is 0, and as the graph continues, it goes closer and or I guess further and further, closer to infinity for the x values. All right, now for the range, let's look at the y values. We look at our lowest y value, which is right there at -1, and as our graph increases, as our graph goes up, the y values increase as well. Look at those points. Those y values are getting bigger and bigger. So our graph begins at what, -1 we said? Our range from -1 to infinity. This is the y, bottom. All right. Describe the transformation from the parent function for the following equation. All right, so we're looking back at what we had earlier at the top of our page. Here's our h, here's our k, okay, and h here is -2. We know x lies, so h is really a +2, which means we're moving to the right. K is a +3, which means we're moving up. So we have a shift right and a shift up. All right, moving down, and if I'm moving too fast, make sure you pause the video. Solve the following cube root equation. All right, so now we are solving, which means we want to get x by itself. So before we can touch this x, it is inside the cube root. So how do we get rid of the cube root? We cube both sides. Cubing that cube root cancels out the root and leaves us with just 3x on the left and 3 cubed on the right. Now you can put 3 cubed into your calculator and you'd get 27. Now we can divide by 3. We get x equals 9. All right, the next one. Here's another cube root. We cannot touch x or -2 because they're inside. We can't get inside until we get rid of the root. So we are canceling that root, leaving us with x minus 2. 4 cubed, when you put that in a calculator, it's 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 32, 64. So we have 64 on the right. To solve, we're going to add 2, leaving us with x equals 66. All right, solve the following cube root equation. Okay, again, we can't touch that x minus 6, but we actually can't even touch that root either until we get rid of the plus 4. So in these problems, we need to first isolate the square root. Isolate the radical. Anytime we're solving, we need to first isolate the radical. On the last 2 problems we solved, there was nothing hanging out outside of the cube or the root. So it was already isolated. It's already by itself on that one side. Over here on the left, we have not only the root, but we also have this plus 4. So how do we get rid of this plus 4? We're we're going to need to subtract it. And now all we have on the left is our radical. And so now we can cube root both sides. Boom, boom. On the left, we're left with x minus 6. Now negative 2 cubed is going to leave us with negative 8. Now to solve, we're going to add the 6. And that leaves us with x equals 2. Last one on the first page. Solve the following cube root equation. Here's our root. It's alone on the left side. We can't touch the inside until we get rid of the root. How do we get rid of it? We cube it. That leaves us with x plus 10 on the left and 4 cubed on the right. 4 cubed is 64, just like we said in the problem above. And our last step is to subtract the 10. Now, if you're thinking, man, these problems are pretty easy, you're right. The test problems will be pretty identical to these. Not any harder. All right, moving on to the back. Solving square root equations. So notice how these radicals look a little different than the last one. How are they different? These are square roots, so the number 2, not the number 3. So to solve these, we're going to go right into squaring both sides. And 6 squared is 36. So we're going to leave that 36 on the right. Divide by 3, and we get 12. Next one, here we definitely need to isolate that radical. It's not by itself on the left, so we need to subtract 5 over. Now, the radical is all by itself on the left side, so we need to square both sides, cancel it out. Now, I know once problems get to this point right here, some of us get a little confused, but here the negative is attached to the x, not the 4. The 4 is positive. How do I know it's positive? There's no sign in front of it. So we're going to subtract the 4. And we're left with negative x equals 5. Really, there's a negative 1 right there. So when we divide by negative 1, all that happens is the negative switches from the x to the other side, to the 5. And now we have x equals negative 5. All right, solve the square root equation. The square root on the left is already isolated, so I just need to go ahead and get rid of that square root by squaring it. And I'm noticing that I have an x squared and an x. When an x squared and an x are present, this automatically tells me this is going to be a quadratic equation. When we have a quadratic equation, we need to bring everything over to one side so that our equation is written in standard form. This is standard form. So we have the x squared on the right. So all we're going to do is subtract everything over the left, leaving us with 0 on the left. Now we can identify what our a, b, and c is. We can factor and set our factors equal to 0. This is how we solve quadratics, by factoring. So we have a three terms, so we're going to factor using a, b, c. Negative 8, our c value, goes at the top, and negative 2, the b value, goes at the bottom. So we need factors of 8. We got 1 and 8, 2 and 4. Now one of these pairs has a difference of 2. If we have a positive 2 minus 4, that leaves us with that negative 2. So those are our two factors here, x plus 2 and x minus 4. Now to solve these, all we're going to do is set these equal to 0. And we add and subtract them to the other side, leaving us with x equals -2 and x equals 4. Now, when we have a quadratic, we get two possible solutions, but only one of them is true. So when it says check for extraneous solutions, we're going to take that answer and plug it back into the original equation. Here. All right, so checking for extraneous solutions, let's start with -2 first. So starting with -2 first, we're going to have the square root of 2 times -2. And all I'm doing is taking this x value and plugging it into the original equation. So we have 2 times -2 plus 8 equals -2. On the other side, we have the square root of 2 times 4 plus 8 equals 4. All right, checking our answers now. We have -2 times 2, which is -4. -4 plus 8 is 4. So we have the square root of 4 equals -2. Square root of 4 is 2. Does 2 equal -2? No, this is our false solution. Let's check the 4. We have 2 times 4, which is 8. 8 plus 8 is 16. The square root of 16 is 4. Does 4 equal 4? Yes. So this is our true solution. All right, next problem. Solve the square root equation. All right, so we got the square root on both sides. How do we get rid of the square root? We square it. And what you do to one side, you have to do to the other. So squaring that, we are left with x squared minus 2 equals x plus 4. Now, again, I see we have an x squared and an x. So that means we're going to have a quadratic, which means we need to subtract and or add everything to one side. So we have x squared minus x. -2 minus 4 is -6. All right, once we move everything to one side, we can go ahead and factor. We got three terms, so we got to use ABC. -6 at the top, -1 at the bottom, and this -1 is coming from right here in front of the x. Factors of 6 are 1 and 6 and 2 and 3. Now, which of these pairs could add up to a -1 if one of the numbers was negative? This one right here. +2 minus 3 is -1. So our two factors are x plus 2 and x minus 3. Got to set these equal to 0, and we find that x is -2 and x is 3. Now, to check for extraneous solutions, again, we're just going to take these numbers and plug them into the original equation. So starting with -2, I'm going to say the square root of -2 squared minus 2 equals the square root of -2 plus 4. And using the 3, we're going to say the square root of 3 squared minus 2 equals the square root of 3 plus 4. All right, so starting with the -2, we have -2 squared, which is 4, minus 2 is 2. So on the left, we have the square root of 2. On the right, we have -2 plus 4, which is 2. So does the square root of 2 equal the square root of true? 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 This 2 is true. And for the 3, 3 squared is 9, minus 2 is 7. We have the square root of 7. And on the right, we have the square root of 3 plus 4, which is also the square root of 7. Surely I did something wrong here. Negative 2 squared is 4. Minus 2 is 2. Negative 2 plus 4 is 2. Three squared is 9. Minus 2 is 7. 3 plus 4. This is weird. What did I do wrong? One moment. Okay, I had to double check because in this case, both of the solutions do work because the square root is on both sides. Usually only one solution works because there's only one square root. Now when we plug that back into the square root on this problem, they canceled out. So they both work. But on this one, when there's only one square root, only one of them is going to work. All right, let's finish this up really quick. 7.2, adding and subtracting polynomials. When we add polynomials, we just combine like terms. Let's write that on here. Combine like terms. That's all we have to do. So I'm going to circle everything with a cube. So that's 2 plus 4, so we have 6x cubed. Next we'll do the squares. I'll square those. That one and that one. So we have 6 minus 1, which is 5x squared. Next we have just the x's, and I have 3 minus 2, which is a positive 1x. And last we have negative 2 plus 6. So 6 minus 2 is 4. And there's our final answer. All we did was combine like terms. When we add, we just add the coefficients. The exponents don't change. Let's make a note of that. Exponents don't change when adding or subtracting too. So we should say that, adding or subtracting. Only when we multiply or divide. All right, now the second one, we are subtracting. Anytime we subtract, we want to change it to a positive and change the signs of everything in that second set of parentheses. So we're almost like distributing a negative 1. We're multiplying negative 1 to all the terms in that second set of parentheses. So we change the signs. We can even do it this way. I think in class, I more so just kind of like change the signs below and then crossed out that first row. So all I did was go ahead and change the signs, rewrite it, and now I have an easy addition problem where all I need to do is combine the like terms. So for subtraction, change signs, and combine like terms. So combining our like terms, we have a cube here and a cube here. We've got a different color. Cube here, so that's 2 minus 4. That's a negative 2x cubed. Next we have 6x squared plus 1x squared. That's a 7x squared. Then we have 3 plus 2 for a 5x. And a negative 2 minus 6 for a negative 8. And there's our final answer. Next section. All right, last two. We have multiplying polynomials. When we multiply, we need to just distribute or double distribute or FOIL, whatever you want to call it. And then we combine like terms. So let's put our steps here. Distribute, combine like terms. So step 1, let's start with 5x. Oops. 5x times x squared is 5x cubed. Here, when we multiply the coefficients. Okay, this looks horrible, I'm so sorry. Multiply coefficients, add exponent. So we have 5x cubed plus 10x squared. 5x times negative 3 is negative 15x. And let's start with the next number. Negative 4 times x squared is negative 4x squared. Negative 4 times 2x is negative 8x. And last we have negative 4 times negative 3 for a positive 12. And now we can add all these things together vertically. 5x cubed, 10 minus 4 is 6. Notice how I place the same x's above each other so that I can just add them vertically. 15 minus 8, that's a negative 23x, and plus 12. There's our answer. For the last one here, we have x plus 7 times this polynomial. So x times negative 2x squared is negative 2x cubed. X times 9x is 9x squared. And x times negative 5 is negative 5x. Move on to the next one. 7 times negative 2x squared, we have negative 14x squared. 7 times 9x is 63. And 7 times negative 5 is negative 35. Now we can combine everything vertically. We have negative 2x cubed, 9 minus 14, which is negative 5, 63 minus 5, which is 58, and negative 35. Oh, there we go. And that concludes your first section of the review. Let me know or let your teacher know if you have any questions.